Right, welcome. My name's Ryan Nix. I am a partner solutions architect with Amazon Web Services. I work with our partners specifically around application platforms and modernization practices. And in the last 18 months, an interesting trend sort of surfaced. I ended up with enterprise customers coming to me with a rather consistent request. Or shall I say a rather consistent goal, that of we want our very, very large historical enterprise business to be able to deliver things to customers far sooner than we have in the past. So a desire for agility. And in speaking to these customers, it was an interesting journey to see what their request was and how they unpacked those solutions. And I think I need to stand there. Right, so that's like the perfect storm. So what we did is started engaging with various customers to see what they essentially wanted. And the customer demographic was a Fortune 500, Fortune 1000 enterprise level customer, usually a very large technical debt footprint, a large-scale investment into their own data centers, their own infrastructure over time. Some of them still very much entrenched into that sort of platform, some of them existing on the cloud already, some of them migrating to the cloud, but in almost every single customer case there was some element of a hybrid play, some element of making sure that applications are delivered to multiple locations. And out of all of the requests that we got from these customers, the things that they were chasing, and it was quite a diverse list. The obvious ones are security and compliance and all the rest of it, but the top two that stood out were a requirement for agility, a requirement to get things to their customer faster, chasing the startup type entity. And if you look at something like an Airbnb, for example, Airbnb has the ability to take a new feature coming in as a request from a customer, build that out, take it through test, UAT, and put it into production in a cadence of days with an operational team of something like 4 people. It's a ridiculously high velocity when you compare it to a traditional enterprise. And a lot of the banks, airlines I was engaging with said, we want to be able to get closer to that sort of experience with our application development teams and our customers. Another requirement that came through was a requirement for portability, the ability to take an application workload and deploy it wherever I see fit, either into an on-premises context or move it into the cloud, or in some cases a very large density of multiple on-premise providers, or in some cases multiple cloud offerings. That portability was essential, but with a little bit of fine print at the bottom of the page. A single pane of glass. I don't want my development and operations teams to swap hats, context switch. I don't want a different process or a different interface. So taking those couple of things, I want to focus on the agility side of it primarily today. Agility is not a new concept. We've been chasing agility in the industry for many years now. I can remember 15, 20 years ago, my day job was trying to find ways of doing less manual process, and in my context that was scripting automation so that I could spend more time with my family or focus on other things. So why are we talking about agility in this day and age? It's not a new concept. I think what is new is agility has very many layers to it. It is the proverbial onion in the industry right now. So very quickly, looking at some of the customers I'm engaging with, and specifically the enterprises moving from their traditional data centers onto AWS, a couple of things came into the foreground when I asked those customers why the decision to move to AWS. Top of the list, surprisingly enough, agility came through. The ability for a customer to take pretty much everything that they were building infrastructure-wise in their on-premises data center, and they could build it faster when they transitioned into an Amazon cloud context. To get a feel for this, I engaged a financial institution and I said, give me a perspective, give me a feeling of how long it takes you to stand up physical infrastructure within your environment. And they was quite honest with me. They said by the time that they go to the finance team and they go through a motivation to get new physical tin. They go through the procurement process, payment, to the delivery from their vendor. So from the time that they request the hardware to the time that it arrives on premise, this is hardware delivery. They haven't put it into the rack yet. They haven't started deploying onto it yet. 16 weeks. I was flabbergasted. 16 weeks. If I waited 16 weeks for an application to go into production, my customers would up and leave and go somewhere else. To contrast that, the same customer moving to AWS was able to spin up cloud-based resources in minutes, simple API call server infrastructures there. To look at the networking side of things, if I was crafting a network 20 years ago, it was physical device configurations, it was cable layouts, it was VLANs, physical network configurations. Doing that on AWS, if I manually craft it, it's button clicks or API calls. If I put a bit more effort in and I script that out, or I use something like an infrastructure as code platform, I can accelerate that process and repeat it in a very attractive fashion to the likes of an enterprise customer. And then we get the very common AWS value proposition things coming through from my customers. All of them listed a heightened availability. They could reach a uptime or a resilience that was not necessarily financially possible in their on-premises data context. They could get there to some degree, but when you're comparing apples and apples, it was a very, very different ballgame. Scalability, again, coming back to a virtualization context on premise, many customers said, you know, we have the ability to scale, we have the ability to add virtual machines, but only to the degree that our physical underlying hosts cater for, and the minute we exceed that capacity, we're trapped inside that long-winded procurement process. Transitioning to AWS, we could scale up as much as the credit card caters for, essentially, near infinite at the will of a couple of API calls. And then the security side of things was also very attractive. That being said, if I look at the journey from a virtualization stack from on-premise into cloud, that gave many customers a degree of agility, the ability to manage the infrastructure side in a more agile space, but it's not enough. That alone does not translate to an application getting to a customer and that customer being able to consume that application. So what came next? Many of us have already started this journey. The concept of how do I get my development process and my operational deployment processes more streamlined. So the concept of DevOps, the concept of that shift to the left where development teams are in many ways owning parts of the infrastructure, containers becoming a big part of this journey, orchestration becoming a big part of this journey. And then I realized that for many of the customers I'm working with, they have DevOps practice, but a lot of that DevOps practice is still very much a manual process. There's collaboration, communication between developers and operations, but at some point in time, when that application goes into production, there was very commonly a manual process at play. And the customers that we identified being incredibly successful or incredibly agile had achieved a very different degree of automation. There was automation all the way through the spectrum. So it was a developer taking a code, writing that code, pushing it into a Git repository, some sort of pipeline technology, detecting that change, picking it up, actioning the next step, going through a build process. If you're talking containers, we've got a container build process happening, and then actually pushing that into a development environment for further scrutiny and testing. So whether that's UAT testing or whether it's security analysis, the development side I found most customers were doing. The automation going into production, however, was a little different. So when we started digging under the hood with many of these enterprise customers, I discovered something called a near shift to the left. Automation and really good DevOps practice in the development space while in dev. And when that customer started moving into a production context, I started seeing other trends. again, this manual process surfaced. It'd go through dev automatically. When it moved into production, a manual scrutiny of that application. In many cases, the security process became a bit of a bottleneck. No security in dev. The minute I go into production, I suddenly have a requirement for security. My application goes to the SecOps team. SecOps starts interrogating that application for the first time. They have to run through a massive compilation of code, and then they find something that is undesirable and push it back to the dev team. Now the dev team gets frustrated because what they really wanted was to push it into production, and it's not going there. Instead of highlighting small incremental little issues with the application, there's now this almost monolithic list of issues coming from the security team, and the dev team now has to address all of those. And these are not difficult challenges to fix in some cases. So what we started unpacking with the successful customers was, yes, there's DevOps, yes, there's automation, but this needed to extend further into the organization. And we started looking at some of the more successful financial institutions, some of the more successful airline industries, and we noticed an interesting shift additionally to the left, not just DevOps, but DevSecOps, bringing the security team into the fold and bringing them into the journey significantly earlier on in that development cycle, that application journey. And 5 tenets consistently came to the foreground when looking at the security side of it. And that was, if you're expecting your applications to be agile, if you're expecting your development teams to be able to take that application and get it to the customer faster, your security process has to mimic that same journey. Your security process in itself has to be equally as agile as your development process. And it's going to consume many, if not all, of the exact same tools. So if you have an automated pipeline as part of your DevOps process, your security team is going to take advantage of that pipelining technology. So what we see is this change from a developer pushing code into a Git repository, pipeline picking that up. The pipeline's not just building out the application or building out a container. Another parallel pipeline is implementing the security checks, static code analysis at the Git level, container scanning and vulnerability assessments at the containers level. Everything that the security team is doing starts on day one, the minute the developer clicks on a commit or pushes that to a repo. Security happens at the same time. The other thing is not just automated, but it is continuous. Several customers I spoke to had a very evolved security practice leading up to production. Once they got into production, there was this mindset of, I've assessed the security posture, we've whitelisted this platform, it is secure, and they never checked it again. And I was raising questions, but what if there's a vulnerability that surfaces later on? And like, do you just wait for something to happen that's catastrophic? And again, we went back and looked at the successful customers, and what they were doing is they were taking this continuous automated process, and they were saying, even if the application is live in production, we still go back and reassess that application for new risks, new concerns, and we address them in the environment. Now some of us in the room are obviously doing this, I hope. Right. The other thing that was very attractive to these successful customers was a concept of collaboration. It wasn't a case of developers were writing code, operations were maintaining that application, and then security was this ring-fenced silo team that was focused on security. All of those individuals were collaboratively involved in the application process. The developers had a clear understanding of what was important to the securities team. The securities team had a clear understanding of what the goals and what was important to the developers. Everybody was working towards a unified goal, a unified way of getting the application out. What this resulted in was when something was highlighted from a security perspective, yes, the security team detected it, but they didn't have to communicate it to the developers. The developers had the access to the same tooling, the same reporting, and the developers themselves could see what was coming up as a risk, and the developers immediately became aware of it and could start addressing it. One customer I spoke to even went as far in their open plan development floor, to have giant monitors, and every time their automation process did a build of an application, went through security posturing, if anything was detected that was untoward, it would come up on these boards. So picture an open plan office or developer sitting and suddenly all these boards go red, highlighting an issue. Not that team who built the app, every single development team became aware of it. Not in the context of a shaming process, but collaborative learning. My development team could be using the same building blocks, same frameworks, something similar to another team. And if I detect a problem there, suddenly my team goes, I need to take a step back and I need to check what I'm doing. And much more rapid break-fix process from a development and securities point of view. Right, so a couple of things here. We've got automation coming into play. We have a shift to the left, that developer enablement coming through from a DevOps process. We saw AWS and cloud coming into the picture quite significantly. The concept of DevSecOps being entrenched. And this required a fairly in-depth organizational change management process. This didn't happen with small pockets of the organization. It was very much a top-down driven mentality in those successful customers. And even if we took all of these things and put them together, I still had customers coming to me and saying, it's not agile enough, I still want to go faster. So what was the missing layer? Right, so a couple of things came to the foreground. Developers shifting to the left. Some companies were taking the developer and saying, my developer needs to be a DevOps person. Suddenly my developers now are learning development processes, and they're learning containers, and they're learning networking, and they're learning storage, and they're wearing many hats. And what this created in some companies was a developer who was a jack of all trades, but couldn't really take advantage of what that person was very, very good at. So if I look at other customer spaces, there was this focus of, let's focus on what my teams are great at. Let's take advantage of that. So let the developers develop. Let the operations teams operate. Let securities focus on security, but let them talk to each other. Let there be communication, but leverage everybody's inherent skill set. Reduced hat swapping, reduced context switching, a faster ramp-up time because I don't have to learn every single skill set. And we needed a set of tools and a set of frameworks to facilitate that. And Cloud Foundry came into the picture as a developer productivity acceleration technology. Cloud Foundry allowed developers to take advantage of frameworks, take advantage of reusable code blocks, native cloud development practices, and really accelerate the dev team. So now what we're seeing is we've got that acceleration from the underlying infrastructure, and now thanks to Cloud Foundry, many customers were getting an acceleration within the development cycle, churning out applications faster, and when you shift that into an automated DevOps context, you get an additional agility in terms of pushing that code that you've built out into a production environment. Right. Looking at the most recent Cloud Foundry user survey, this is a 2018 data, a consistent theme that came back from that survey was customers were aiming to build more applications in less time. Microservices, not just the individual services themselves, but the aggregate applications that they're getting out into the market. Liberty Mutual, for example, building an entire customer portal for their customer base in 6 months from the ground up. Whole new application platform with a plethora of underlying microservices. Looking at Cloud Foundry's user stats, a significant portion of customers reported cost and time savings, a reduction of near 6 months. It came through in 10% of the customers that reported back. 6 months quicker to build an application, which means you're able to take that team and build another application. Your customer is able to consume that application and start using it, which puts you ahead of your competitor. utterly disruptive. I saw it in the banking industry. One financial institution is able to push out an application faster than the next. It creates an industry knee-jerk. Suddenly every bank is looking at those technologies, those platforms, those processes and trying to implement them. We saw them in the airline industry. One airline comes out the door with a new platform faster. Suddenly every single airline I'm talking to is saying, we want more agility. And it's cascading from industry to industry to industry to the point that now I'm talking to the public sector space and they also want it. That's a little bit more complex though. What was interesting is not just a time saving factor, it was also a money saving factor. If I can get the application out the door faster, if I'm outsourcing my development, I'm paying for those developers' time. Per project, customers were reporting savings of $500,000 to $1 million per development project, which can be reinvested in testing, reinvested in infrastructure, reinvested in other projects. And this is all from the 2018 CF user report. The problem with Cloud Foundry is not something that can be implemented with the greatest of ease. Many of the Cloud Foundry implementations you see in the market nowadays are coupled with a costly, long-winded consulting element. Somebody comes in and holds your hand through building out Cloud Foundry in your organization. It's not difficult, it's not easy to implement, it's not easy to maintain. Many of these have an infrastructure layer that is Cloud Foundry itself, the master nodes, the database systems. They are resilient, they are highly available, but if something breaks, somebody in the organization still has to come in and fix the failed component. You still need to eject a master node out of that environment, replace it. If there's a database level failure, yes, there's another node that carries on that function, but somebody has to go and eject that failed node out, bring the new database in, and fix the replication in that process. So customers said, you know, we want something that's easier to implement. We want something that is going to manage itself in many cases. Why can't we get something that is not just resilient, but has an element of automatic healing, as we are seeing with other things in the cloud space? And this is where SUSE came into the picture. SUSE did something incredibly fun. That they took Cloud Foundry as an implementation. The first thing they did was they containerized it. So they took all of the underlying functions, built them into containers. Straight away, this gives me a portability factor. If an underlying physical hosts fail, I can take all of the components of Cloud Foundry as containers, shift them somewhere else, and I get a degree of automatic healing within that environment. What they did a step further is they simplified that by building it on top of a Kubernetes framework. So the adoption of Kubernetes into the industry that we're seeing, something like 56% of all Kubernetes workloads are running on AWS right now. Huge uptake in the last few years. A lot of interest in Kubernetes, a lot of skill set in the Kubernetes space. Let's take advantage of that. So take Cloud Foundry as a developer acceleration technology, put it on top of Kubernetes, and suddenly a very lightweight footprint, something that's easy to implement, something that is incredibly easy to manage and maintain. There is automation. You're dealing with it from a Kubernetes standpoint, so if you already have a Kubernetes shop, it's something that is inherently familiar to your operations teams. And it is not only fault tolerant by design, it also takes advantage of that element of auto healing. So really simplifying the installation, simplifying the day-to-day management of Cloud Foundry, which many customers were looking for. All right, taking a step further into that, moving into an AWS context, what we did is we teamed up with the engineering team from SUSE, and we built a AWS Quickstart. This is an infrastructure as code template. It's based on AWS CloudFormation. And what we've done is we've taken all of the bits and bobs from an AWS perspective, the networking infrastructure, the VPC. We've taken SUSE's Cloud Foundry implementation, cloud application platform, and built it on there. So a customer doesn't have to go through a very long-winded documentation process or stand this up themselves. They can go to the quick start, and by filling in a few very, very simple parameters on a form, kick off that infrastructure as code template, and stand up cloud application platform on AWS. I asked the question, how much faster is it? I'm used to things like this in the environment taking 2 hours, 4 hours. Yes, they're automated. You fill in the form, you go away for lunch, you come back, you have an environment. And I was expecting something in that 1 to 2 hour range. 45 minutes for a resilient, up and running Cloud Foundry implementation on top of AWS. That caught me off guard. That's quick. So whether this is a POC assessment, or whether you want this in a production context, or whether you're standing up another foundation for another team in the business, 45 minutes to get them up and running, I like that number. Right, very quickly stepping aside and jumping into a browser. If you go to aws.amazon.com/quickstart, you'll find all of the quick starts themselves. I've just drilled into the cloud application platform one. There is a comprehensive deployment guide. This runs you through not just the deployment process, but a architectural best practices guide for running cloud application platform on top of AWS. Is my internet broken, or is the link broken? We launched this on Monday, so I'm anticipating a little bit of a teething problem. No, this looks like an internet issue. Page unresponsive. Wow. Right, let me do this the long way. So this is the AWS console. I'm in, oh, there we go, no internet. While that's loading, it's essentially a couple of parameters you need to fill in, and the most significantly, it's the number of nodes that you want. So do you want to start with 2? Do you want to start with 4? You fill in those parameters and it builds out the entire environment. I do encourage you, take some time, go to the quick start page, go look at Cloud Application Platform on AWS, test drive it, run with it, unpack it. Great way to explore the product. Coming back to...
Can I just ask?
Yes, by all means.
So that is a complete environment that has all your development tools that you need to be able to develop a cloud application?
Well, I won't say complete development tools. So the missing piece that I want to add in is a CLI tool that allows developers to interact with Cloud Foundry. So the big focus here is I don't want to change my development team's tools. I want them to develop in the user interfaces they're familiar with. I want them to interact with the command line tools they're familiar with. So a very simple agent that interacts with the platform. In my case, I'm using something called AWS Cloud 9. It gives me a developer interface, and I've just pulled down the Cloud Foundry CLI. I think they reported something like 20,000 downloads of the CLI monthly. So very common tool to pull down and interact with. And your developers continue developing in much the same way they were in the past. You've just got this platform managing a lot of the build processes and things in the background. Right. The next thing that we are working with SUSE on is the AWS Service Broker, and this came from discussions with customers moving into a cloud context. So great, I've got developers building applications, I can accelerate the build process, but what happens when I look at native AWS services, for example? Do I build a native application and then I build out a MySQL database the way I was on premise? Or do I transition to something that is native available on AWS, like a relational database service? And this created, again, a bit of hat swapping. Development teams were developing an application in one interface, in one tool, then swapping hats, stepping outside of that tool, going to an AWS console and standing up something like a database or a queuing mechanism or a messaging component. Then they had to learn everything about the AWS platform. They had to understand the nitty-gritties of what is requirement to stand up a database on AWS. Then they had to swap hats again and come back to their development implementation and link those two things together. In some customer cases, it was a little bit more aggravated. It was the developer wasn't able to do that. They had to send a request to a cloud or infrastructure team. That team goes and stands up the AWS resource, and then communicates back to the developer. Here's what we built for you. These are the bits and bobs you need to connect to it, the connection strings, the usernames and passwords. And I had a problem with that step, the communication of connection details. Suddenly I've got an operations team and a development team, human beings knowing the usernames, passwords, connection strings. It wasn't ideal. So what we did is we spoke to several customers and they said, we want a single pane of glass. How do we achieve that? So we created a service broker using the Open Service Broker API. The idea here is that you install the service broker into the application platform. In the case of Cloud Application Platform, this runs as a Helm install on the Kubernetes layer, and we then register it back to Cloud Application Platform. Picture this, a developer working within the development environment, and from within the same interface that they're writing their application in, they're not stepping outside of the application, they're not going to the AWS console. From within their development environment, they can create statement, and I can go, Cloud Foundry, create a service. I want an Amazon RDS database, and that create instruction goes to the service broker. Service broker then processes a CloudFormation template in the background, spins up that database for the developer without the developer leaving the environment. The connection details, the endpoints, the usernames, passwords, those are securely stored inside the Cloud Foundry secrets management platform. And then all I do as a developer is I say, great, I've got the service in the background. I want to bind that to my application. Never left the console, never was exposed to the credentials required to connect to that thing. My application works, I stood up the resources. Somewhere in the room I've got a security person screaming now, you're going to let developers run amok and launch? No. So what we did is we created a IAM role for the service broker. The service broker has the permissions to stand up resources in the account, and we're using role-based access control inside Cloud Foundry to control which development teams are able to use this to generate which services. I will try and get back to internet connectivity in a moment, and I'll give you a bit of a guided tour of that. So what we found with customers that were hugely successful was not one or two things. The customers that were achieving a heightened agility were taking advantage of the cloud. They were taking advantage of that availability, the scalability, that API-driven agility. They had very entrenched DevSecOps processes, a lot of team collaboration coming into the play, and really empowering and enabling those teams. That obviously comes through with a degree of change management within the organization. In large enterprises, this was something that took time to instill. It was a mindset shift. And I'd say that's probably the most difficult part of the journey. Automation. SUSE coming into the picture by significantly simplifying a Cloud Foundry implementation through building out Cloud Application Platform, and then technologies like the Service Broker and the Quickstart solutions accelerating those initial steps over there. And where we saw all of these components together, we saw an agility where customers are able to cut down dev times. Applications not just coming into the market 6 months sooner. We started seeing faster release cadences. We started seeing customers shift from I'm releasing new code into my environment in a 2-week cycle. Those cycles came down to daily. Some customers were even launching new applications into the environment 2 or 3 times a day because there was testing and validation in an automated fashion. There was a risk reduction process. Right, let's see if we actually have nothing. Right. The demo gods have officially decided to smite me, so let me see if I can show you a video recording of this. And I did myself a huge favor by not paying attention to where I had saved the recording. Maybe I can do this. Let me see if I can get us to tether through a phone. Is it possible I have a VPN connection? That would imply I'm working. I'm too lazy for that. No, it's not. It just seems to, what I suspect is happening is the Wi-Fi is connecting and I'm not authenticating through to the little portal. I haven't typed in open somewhere, but I will go with a slightly more trusted source, i.e. my phone. Now that I've said that, this will also fail. Yeah. Oh, there we go. Come on. See, that is not what I'm looking for. That looks a little better. Okay, so this is a AWS Cloud 9 developer interface. I've added in the CFCLI. You can see that I've opened up two tabs at the top. One is a AWS console looking at the infrastructure as code, CloudFormation side, as well as an RDS tab. Now remember, I don't want the developer to step outside of the development environment. Those two tabs are just there to show what's happening in the background. So when we get to a developer or operations person doing a simple Cloud Foundry marketplace, and here you can see all of the various AWS products that can be taken advantage of via the service broker. We've created multiple plans, so in the case of RDS or the database environment, you can create a developer implementation or a production implementation. Notice over here, creating the service, I'm going for the dev one. I'm providing two parameters, literally an entry point or a CIDR, where will I be connecting to that database from, and the AWS VPC. No information around, is this multi-AZ, is this going into which specific subnets, am I creating database option groups, am I creating all of the nitty-gritties. What we've done is we've tried to alleviate as much of that from the developer as possible. We're implementing a prescriptive, guided template, and the idea there is that a developer can say, I'm launching this into production, I know this is going to fit my production use case, simply consume it. If it turns into a situation where I want something more specific, they can go and modify the template in the background to build it in the relevance or context for the company. But literally you can see here in the background, you can see that CloudFormation template kicking off. It's building out all of the resources, and all my developer did was from a CF perspective go CF create service, what's the name of the service I want to create, and provide a parameter override. Right, as I said, these are prescriptive, so we've spent a lot of time talking to customers and saying, what is a referenceable best practice approach to deploying a database, for example, in a developer context or a production context? In production, we're seeing things like backups will be there. We're seeing things like encryption at rest is implemented. In the development case, we don't necessarily have the encryption, we don't necessarily have all of the backup and resilience, but the teams can restructure those, overwriting them with parameters or overwriting the templates in the background themselves. Not just does this stand up the resources, but my developer can also go, and you can see over here, it is still referencing as create in progress from the developer's standpoint. Once the stack completes, the stack in the background reports it to the broker, and the broker will eventually come back to the developer and say, right, this has now been completed, the resource is in existence, you can consume it, and at that point my developer can go through a binding process to consume that resource. Very, very quickly, I want to show you the inverse of this, because a question I got from customers is, great, I can stand these things up. When I'm no longer using them, does it translate to residual artifacts in the AWS account? Am I going to end up spending money on things that I'm not aware of? No, because everything's built up via infrastructure as code, from my developer interface, I can tear down that environment as well. So looking at an environment that is already up and running, you can see there my create has succeeded, my database environment is up and running. I can simply go do a Cloud Foundry delete, and I can specify the service name. It's a database, so do you really want to delete this? Should be a very valid question for a production database, I think. That will then kick off the operation status in the background. We'll actually go and see the deleting process here, and likewise when you go to CloudFormation in the background, you will see that stack. Let's just do a refresh. You'll see that delete in progress. Right, so we're going to throw away production data here. No, what we do is when we tear down certain resources, if it's a database, we do a final backup of the data in there. That persists in the account, so that if this was something that was accidental, you can recover that data. If this was an S3 bucket, for example, we retain the S3 bucket. So there are situations where we are leaving behind residual artifacts, but with the philosophy of do no harm. We don't want to destroy data. If this is an EC2 instance or something that has an EBS volume, again, we are creating a snapshot of that EBS volume so that an operations team could recover data if there was a necessity for it. But notice at no point in time is the developer leaving this development interface and they're interacting with AWS. This resulted in a lower entry level to development teams consuming AWS services, and we started to see a much faster modernization of applications. Applications that were running in an on-premises context, we started seeing customers very quickly replace databases, caching mechanisms, queuing and messaging components within their microservices architectures, and being able to take advantage of those highly scalable, highly resilient native AWS services within their platforms. Quickly running back to PowerPoint. A couple of questions. I think we've got a few minutes before we need to run away. Thank you for joining me.